All right, algebra students, we're back. And now we're going to deal with some of those that I was talking about earlier about how we can't leave a radical on the bottom. I think as I'm looking at all these, all of them will leave a radical at the bottom, so it creates a problem. But that's okay. Let's see how we can work this first. So let's look at the first one. Square root of 2 over square root of 3. You know what I like about this? They didn't try and trick us. They didn't write it like this one, where they put one big square root. They put two little ones, which is okay. Now, square root of 2 and square root of 3, they're both less than 4. So I cannot do anything with them as far as simplifying. They're where they're at. But I have a major problem. You can't leave a radical on the bottom. You have to move it up. Well, how are we going to do that? Well, I'm going to use a really basic rule. I'm going to look at both of these numbers. I'm going to say this to myself. I'm going to say second square root of 3. Now, if I have square root of 3 and I multiply it by square root, and I multiply square root of 3 by square root of 3, I multiply it by itself, what's the answer? 3. Okay. I multiply any number. I'm going to pick a random number. Well, let's do square root of 2, because that's a popular one, times second square root of 2, hit enter. It's 2. So if you multiply these, let's make up another number, 10. Let's make another square root number. Second square root of 10 times second square root of 10. Check it out, 10. So if I multiply it by itself, it's the same. I'm going to use this idea here. So here's what I'm going to say. I'm going to say, well, square root of 2 over square root of 3. Now, if I multiply it by a number that's not going to change it, I could always multiply it by 1. Anything by 1 is itself. 2 times 1 is 2. 3 times 1 is 3. 4 times 1 is 4. So I'm going to use that thing, but my 1 is going to look different. My 1 that I'm going to multiply our number by is going to be this. Square root of 3 over square root of 3. Square root of 3 divided by square root of 3 divided by, instead of multiply this time, is just 1. Okay, so that's a special type of 1. I'm writing 1 in a really funny way, but it's going to work. Square root of 3 times square root of 3, we already established that. First thing we did here. Square root of 3 times the square root of 3 is just 3. So as I'm multiplying here, the bottom number is just 3. There solves our problem. We no longer have a radical on the bottom. The trick is just what to do to the top. Well, we remember that when we're working with these, we can just take those two numbers and multiply them by themselves. 2 times 3. 2 times 3 is this, square root of 6 over 3. No longer have a radical on the bottom. And it's pretty simple. Now, I'm going to look at square root of 6 and see if I can do anything with it. Well, let's see. The only perfect square that's smaller than square root of 6 is 4. So I'm going to do, let's clear this out. Clear. 6 divided by 4. 1.5. It's a decimal, so I can't even do anything. That is the end. Done. Okay, not bad. Next one. All right. Square root of 5 over or divided by the square root of 18m. That's a tough one. Okay, but we'll get through it. We'll get through this. Okay, so let's... what do we want to do first? Well, we can do this. It doesn't matter what we're going to do. I'm going to get rid of this 18m first. Okay? And then I'll deal with everything up here. Once I deal with everything up here, we'll be okay. Okay, so I'm going to take this and divide it by our special 1. Our special 1 is square root of 18m over square root of 18m. This times this on the bottom, remember, it just becomes whatever's underneath there. It's just we got rid of it. That's what we wanted to do. On top, we have square root of 5 times the square root of 18m. Okay, well, we got rid of it at the bottom, so we're kind of halfway there. Now, remember, from the last one, when I have these up here, I can just multiply them together. Well, I can multiply 5 and 18. 5 times 18 gives me 90. Okay, that's not bad. And m over 18m. All right, so now I get into my whole problem here. What number? Now, here on the bottom, I can leave this right now. Nothing to do. What I want to simplify this radical. Well, I can't really do m, if you remember from before. It's a odd number, 1, so I kind of have to leave that. That is probably going to stay till the end of the problem. I'm not going to move that over 18m. What I have to do is simplify 90. That's my job. So the question is, what number goes evenly, of our perfect squares goes evenly to 90? I'm going to start using my list here. 90 divided by 81. I doubt that's going to work. Decimal, move on. 90 divided by 64. 1.4, move on. 90 divided by 49. Decimal, move on. 90 divided by 36. Decimal, move on. 90 divided by 25. This is not looking good, right? 3.6. 90 divided by 16. Decimal, move on. 90 divided by 9. Boom. 9 times 10. So this is really square root of 9. So square root of 90 is really square root of 9, square root of 10 times square root of m over 18m. Now, square root of 9 is just 3. These, square root of 10, if we check it out, there's only 2. 10 divided by 9 is a decimal. 10 divided by 4 is a decimal, so I don't have a way to fix it. So I'm just going to call it 10 and multiply it by m, 10m, all over 18m. Almost done. I mean, this is pretty impressive if you got to this point. Now, 3 and 18 can be reduced. 3 goes into 3 one time, so I can make this 1. 3 divided by 3 is 1, so I'm going to divide it by 1. It shouldn't change it, and that makes it 10m. 18 divided by 3, well, that's just 6m. So our final answer, 10 at square root of 10m over 6m. Annoyed yet? Well, let's look at the next one. C, I think, might be a little bit easier. I think we're going to look at this one. I'm going to be pleasantly surprised. Again, I don't like how they write this. That's how I would write it. It's too confusing. Now, square root of 3, that is smaller than 4. So there's no perfect squares I could fit inside square root of 3. So I'm going to have to leave that. In a sense, I can't make it any easier. Square root of 7, well, 7 divided by 4 is a decimal, so I can't use that. So that was our only option up there. So almost, I can't really simplify this much. But I have to get the radical out of the bottom here. This radical 3 has to stop. So I'll just use our rule that we've been using. Square root of 7s over square root of 3, and I'm going to multiply it by the funny 1. Same number, actually we used over here, but here we're going to use square root of 3 over square root of 3. It's 1 in a funny way. Square root of 3 divided by times square root of 3, if you remember, it's just 3. On top, now I have square root of 7s times the square root of 3, which I can put together. Square root of 3 times square root of 7s is 21. 7 times 3, s, over 3. Now I can check real quick. I can say, well, could I reduce 21? Can't reduce s because that has an exponent of 1, but 21. So I'm going to go through my perfect squares that are smaller than 21. 21 divided by 16, nope. 21 divided by 9, decimal, nope. 21 divided by 4, decimal, nope. So these don't work. So this ends up being our final answer. Okay, I will talk to you tomorrow. Actually, I'm going to take 1 second. If you're still on, remember, get that Desmos calculator. You need it.